In Chapter 9, we're going to be looking at polynomials. And we've seen these before, but now we're going to look specifically at rules of working with polynomials in terms of how do we perform operations with them, and towards the end of the chapter, how do we factor polynomials. So first of all, let's look at a monomial. A monomial is a number variable, or the product of a number and one or more variables with whole number exponents. So here we have just one term at a time. So for example, -5 is a monomial. Y is a monomial. First we had a number, now we have a variable, now we have a number times a variable. 3x squared is a monomial, and here we have a number times two variables, -4x cubed y to the 6th. That's still a monomial. Notice that there's no addition or subtraction taking place within these terms. Now sometimes we want to talk about the degree of a monomial, and this is the sum of the exponents of the variables in the monomial. So for example, when you look at -5, just a constant by itself, there is no variable, so if you wanted you could say that's -5, for example, x to the 0 power, but at any rate the sum of all the exponents is 0 because there are no exponents. Here with y, we have y to the first power, so the degree is 1. 3x squared, the degree is 2, the exponent of x. Now when you have more than one variable, we need to add the exponents. So here we have an exponent of 3 for x and 6 for y. We add that together to get degree 9. Now for a polynomial, and I apologize here, but there's a typo. A polynomial is, a sum of monomials. Sum telling us that we're adding or subtracting, because that's the same as adding a negative. So each monomial within a polynomial is called a term. So a binomial is a polynomial with two terms. So for example, you could have 4x minus 7. That's a binomial. You have one term, second term separated by subtraction. Or a trinomial is a polynomial with three terms. So for example, we could have x squared plus 2x plus 8. Alright, so those are examples of polynomials. Now for the degree of a polynomial, we look at the greatest degree out of all of the terms. So for example, with x squared plus 7x plus 10, we have degree 2, degree 1, and degree 0. So we go with the largest degree. The greatest degree is 2, so that's the degree of the polynomial overall. Now notice that these are written in decreasing order. We started with our largest degree first and then went in descending order, and that's going to be a convention that we need to follow. Speaking of which, here it is. Our convention is to write the terms in decreasing order of degree, and then when we write in that way, then the coefficient of the first term is called the leading coefficient. So in our example here, 7x squared minus 5 plus 4x cubed minus 12x. We want to rewrite that so that we have the greatest degree first. So here we have degree 2, degree 0, degree 3, and degree 1. So we want to start with degree 3, so 4x cubed should go first, and then degree 2. 7x squared, it's a positive, so we add 7x squared. Degree 1, we have a negative 12x here, so minus 12x. And then finally our constant, degree 0, -5 or minus 5. So this would be written here in our conventional form, going in order from left to right, decreasing or descending degree. And our leading coefficient here, now that it's written in that order, is the coefficient of the first term. So in other words, 4. Okay, so that's an either. All right. Now, adding or subtracting polynomials, which is the point of this section. In order to do this, we're going to combine like terms. We've already worked with this before, so this shouldn't be terribly new. So this is when you combine terms that have the same variables, and those variables have to have the same exponent for each variable. All right, so let's look at some examples here. So here we have simplify each sum. So we have 3x minus 8 plus 5x plus 2. If you want, you can look at the degree of each term. This is degree 1, degree 0, degree 1, degree 0. So we have degree 1, x is our variable. Those will combine. So we have 3x plus 5x will go together. And then our constants, negative 8 plus 2. So we end up with 8x plus negative 6, or in other words, we'll normally write this as 8x minus 6. So we combined our terms with x and then combined our constants. Okay, number 2, negative 4x plus 8x squared equals negative 2x plus 9. So let's look again at the degree. Now you don't have to write the degree above here like I'm doing. I'm just trying to show you why we're combining the terms that we combine. Okay, so if we look at those degrees, now notice the greatest degree is right here, so that term goes first, 8x squared. That's the only term with degree 2, so we move on. We have two terms with degree 1. We have a negative 4x plus a negative 2x. Those are degree 1. And then we just have the 1 constant with degree 0. So now we combine here and we get 8x squared. We have negative 4x plus negative 2x is minus 6x plus 9. Alright, let's move on. Number 3, we have 9x cubed plus 2x plus 8 plus, and then our second polynomial, a trinomial here, 7x to the 4th minus 3x minus 2. And by the way, I could mention here, you might be asked in some problems to identify a polynomial by number and degree. So by number we mean how many terms. This is a trinomial of degree 3, and in our second case we have a trinomial again, but now of degree 4 because we have an exponent of 4. So our greatest degree here is 4. That term goes first. So 7x to the 4th. We only have one term with degree 3. That goes next, plus 9x cubed. We don't have any term with degree 2, so we continue on, descending order, degree 1. We have a 2x minus 3x is negative 1x, or in other words, minus x. And then look at our constants. We have a positive 8 plus negative 2 will give us plus 6. And now for the next few examples, the directions are to simplify each difference. So we're going to be subtracting here. Same idea, just be careful of your signs. So if you want, you can look at the degree here. 1, 2, 0, 2, 0. So we have two terms with degree 2. We deal with those first. So we have 6x squared minus 4x squared. That will go first. Okay, plus, now degree 1, we just have that 8x. And then for our constants, we have a negative 5 minus negative 14. Okay, so for degree 2, we end up with 2x squared plus 8x, and then negative 5 minus a negative 14 is a positive 9, so we have plus 9. Okay, number 5, 7x plus 5 minus 3y plus 3. Again, if we want to look at the degree here, we have 1, 0, 1, 0, but in this case, notice that our terms of degree 1 don't have the same variable, x versus y, so these cannot be combined. Now it's typical when you have more than one variable to list them, especially when they're the same degree, to list them in alphabetical order. So normally the way you'll see this is our term with x will go first, then our term with y, so minus 3y because we're subtracting 3y, and then our constant. We have 5 minus 3 will give us 2. Okay, so we still end up with 3 terms, even though 2 of the terms are degree 1. We can't combine them again because they have different variables. And for number 6, now we get a little more work here. So here we have a polynomial with 4 terms and another polynomial with 4 terms. And notice that here we have x squared y to the first, x squared y squared. Well, that doesn't match up. Here we have xy matches up with xy, so that's good. Then we have x, but over here we have y, and then finally we have our constants. Okay, so now what do? Well, you're going to get a little leeway here, but again, we typically go in alphabetical order, so we want to start with the expression that has x to the largest exponent. And as well, once we determine which term has x to the largest exponent, then we look for y with the largest exponent. So here you have x squared y. Here we have x squared y squared. So this term will take precedence. We're subtracting negative 4x squared y squared. So that becomes a positive 4x squared y squared. Okay, and then we look for any more x squared terms. And here we have negative 3x squared y. So that will go next. Alright, and then we have xy terms. Now we actually have two of them, so we need to combine. We have 4xy minus a positive 3xy. So 4xy minus 3xy will be 1xy, or just xy. Now we look for x by itself, which is right here, plus 8x. Now we have a term with y by itself, so we're subtracting a positive 7y, so minus 7y. And then finally the constants. We have 2 minus negative 6, which is a positive 8. Okay, so notice this one ends up a little bit messy, but hopefully you can follow that okay. And if you can handle this problem, then you should be in good shape. So as always, good luck and enjoy.